Hello and welcome to A Ramble with me. We are busy with IEB's paper 2 from May 2025. Today we are focusing on question 7b. The first part of it is to prove that cos A plus sine A over cos A minus sine A minus cos A minus sine A over cos A plus sine A is equal to 2 tan 2A. So, what stands out for me is that this side, there's a lot going on. Very simple right-hand side, a single term on the right-hand side. So that makes me feel like, okay, maybe it might be worthwhile to try and combine this into one term. So basically to find a lowest common denominator and do the things. So in this case, our one denominator is cos A minus sine A. Our other denominator is cos A plus sine A. So the LCD in this case would be cos A minus sine A times cos A plus sine A, right? And so this is how our proof could go. So we have cos A plus sine A divided by cos A minus sine A, and that's going to need to be times by cos A plus sine A in order to get to our lowest common denominator, but then we'd need to do the same up here. And very important to remember that we're timesing, right? Just, to remember that it's going to be a foily. Right, and then the next term is cos A minus sine A divided by cos A plus sine A, and in order to make that also have the same denominator, working towards this as our common denominator, we're going to need to times it by cos A minus sine A, right? And then we'd need to do the same at the top. Okay, and again, I'll just put brackets here to remind myself that this multiplication is going to be a FOIL, right? So down here, I'll just keep this like this for now. Cos A plus sine A times cos A minus sine A is the common denominator now. And then at the top, we've got cos A plus sine A times by cos A plus sine A. So basically we're squaring it. I'm just going to write it that way for brevity, i.e. I don't feel like writing out cos A plus sine A times cos A plus sine A, right? And then the next term is cos A minus sine A, and this is also being squared, right? This times itself. Okie dokie, let me shrink some things. Right, so let's see what we then have here at the top. So we will have cos squared A, okay, and remember to treat this as a FOIL, so it's not just going to be cos squared A plus sine squared A, there's also a middle term. So cos A times cos A will be, okay, you can do this here, cos A times cos A is cos squared A. Then we're going to have a cos A sine A and another cos A sine A term. So that ends up being two of them, 2 cos A sine A, and then the last term is sine squared A. Then here we need to be careful with our signs. We are going to minus, hey, I think I need to shrink this. Okay. There we go. Oh dear. Let's try that again. Right. So this is going to be cos A times cos A, which is cos squared A, and then we're going to have minus cos A sine A minus cos A sine A, so it's going to be minus 2 cos A sine A. This also needs to be shrunken. Hey, guys. Right, and then the last term is minus sine A times minus sine A, which is plus sine squared A. Okay, and I'm not gonna multiply this one out yet. No, but I probably need to. Okay, no, but just in case there's an opportunity to cancel stuff, I don't know. I'm not going to multiply it out yet. Let's see how far I can get without multiplying it out. Okay, right. So let's have a look-see here. Oh, I need to add a page. Right, so we've got cos squared A minus cos squared A. So these are going to cancel out. Okay, and then we have sine squared A minus sine squared A, right? So those two are also going to cancel out. So then all we're left with at the top is 2 cos 2 cos A sine A minus 2 cos A sine A. So that's going to be 4 cos A sine A. Okay, and there are definitely no opportunities to cancel between the top and the bottom. So I'm going to multiply this out. This is a difference of 2 squares. So this is just going to be cos squared A minus sine squared A. And of course you can verify that. Cos squared A minus cos A sine A plus cos A sine A. So those cancel out, and then minus sine squared A. Right, and the nice thing here as well that I didn't pay attention to initially, but on this side we're talking about the angle A in our ratios, whereas on this side we're talking about the angle 2A. So that kind of hints that we're going to need to use our double angle identities possibly. And indeed, what I see here, the cos A sine A is giving sine 2A, right? And definitely down here, this is just the cos double identity. That is the most straightforward one to see. So this is cos 2A. This is the same as 2 times 2 sine A cos A, right? Which would then be the same as 2 times sine of 2A, right? And then this guy over here is the same as tan of 2A using our quotient identity. So that would be the same as 2 tan of 2A. And from there, we say that is the same as the right-hand side. And that's that on that, kids. Identity proven. Right. What is the next part of the question? It says, determine all the values of A for which the identity is not valid. So I'm just going to copy the identity. Let me just crop it real quick. Done proving now. Okay, so I'm going to look at the tan firstly, because we know that tan is undefined at certain points, right? If you think about the tan graph, there are those asymptotes which indicate places where the tan function is not defined. So that's the one kind of thing that would tell us about where the identity is invalid. We can also look at the denominators of these fractions because we don't want to divide by 0. But I have a feeling that those are also going to just lead back to tan because of the cos and the sine. And so we'll look at it for the sake of completion, but I have a feeling that this is going to give us all the answers we need. So I'm going to start there. So basically, when well, okay, how shall I do this? I think it's easiest for me right now in this moment. So let's look at tan of 2a, and I'm going to draw its graph. Right now for me it's just simplest to think about it as a graph, right? So we know that for y is equal to tan a, the asymptotes are at 90, 270, and so on. Like you just keep adding 180 or subtracting 180. So for tan 2a, where the period is half the normal period, so it won't be, the period is not 180 anymore, it's 90, and the graph looks like a squished version of the original. So where the asymptote, the one asymptote would have been a 90, it then moves to 45 degrees, half of 90. The second asymptote would have been a 270, but it will now occur at half of 270, which is 135 degrees, which you also see is 90 degrees later. So the period of this graph is 90 degrees. It's no longer 180. And then there would have been an asymptote at minus 90, but then we're going to halve that as well, and that becomes an asymptote at your, okay, that's not a very convincing asymptote. So that now becomes an asymptote at minus 45, and then this next one would be minus 135, and so it goes. So then your tan 2a graph kind of looks like that, right? So these are then the values where this guy is undefined. So that would be when, and this is a as opposed to x, y versus a. So when a is equal to 45 degrees plus k 90, where k is an integer, that would be one set of values where this identity is invalid, because this is where tan 2a is undefined. Another way that we could solve this, so if you don't like the graphy route, is we can say, okay, where is oh, I don't know what I want to say actually. Yeah, no, that's pretty much it. Well, we could say that we know that it'll be undefined when 2a is equal to 90 plus k 180, right? Because we know that tan of anything is undefined when the anything is that, right? In this case, the anything is 2a. So we could solve this equation, right? And remember, we don't need to specify the two quadrants explicitly because the k180 takes care of that. So so then we would divide both sides by 2, and we would end up with a is equal to 45 degrees plus k 90. So that's another quicker way actually to arrive at the same thing. So Whoa, 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 who are you? And who, oh my goodness, why is everything so hard right now? She's Louise. So that's the one set of solutions. I'm just going to highlight that real quick. Then the other set of solutions, let's just see. Like I said, I don't think that the causes and the sines are going to give us anything different to what we already have. So the identity will be invalid if this is equal to 0, if this denominator is equal to 0, because we don't want to divide by 0, and also if the other denominator is equal to 0. So let's solve these equations. So these are those equations that turn into tan equations, right? Divide both sides by cos A. So then you have tan A is equal to 1. And so A is equal to, just from knowing your special angles, 45 degrees plus K180. Then this one as well is going to become a tan equation. So I'd say sine A is equal to minus cos A. And then we divide by minus cos A. Well, no, not by minus cos A, just by cos A. And then this would be tan A is equal to negative 1. So this is then, if you think about cost, tan is negative here and here, right? Our ref angle is 45 degrees. So the angle in here, the twin angle in here, will be 180 minus 45 degrees. And then we'll do K180, which will take care of the angles in this quadrant and the angles in this quadrant as well. Okay, let's add one. Oh, I don't need to. The page is there. The page is there. Right, so then that is A is equal to 135 degrees plus K180. So at first sight, at naive sight, these look like different solutions to that. But if you kind of start listing the solutions that each of them generates, so this would be, let's say, 45 degrees plus 180 is 225, plus 180 is 405, plus 180 is 585, and so it goes. And the solutions here would be 135 plus 180 is 315, plus 180 is 495, plus 180, okay, no. And if you kind of look at those together, like let's say on a number plane, on a single number plane, what am I saying? So this would be 45, and then 225, and then 405, and then 585, and then from this set of solutions we would have 135, and then next up we have 315, and then next up we have 495. And if you look at the gap between these, this is 90, right? From here to here is another 90, from here to here is another 90, from here to here, you guessed it, is another 90. From 405 to 495, you're adding 90 again. From 495 to 585, you're adding 90 again. So this is effectively, if you combine these solutions, this is just the same as A is equal to 45 plus K90. which is the solution that we found first. So yeah, that was useless work. However, it built our character, and that's worth something. Right, so that's that on that. Essentially then the answer is this identity is not valid when A is equal to the following values. Right, let's have a look at what the memo thinks of our endeavors. Yeah, I'm just scanning to see if we have any interesting things popping out. No, not to me. They do not pop out. Right, so yeah, thank you for coming along for this ride, and I will catch you another time for another ramble.